podcast of Reimagined Mobility. I'm here with Ian Rust from Revoy. Very interesting company. Well, we'll find out more certainly on the company. The technology, very interesting, addressing a need that everybody's talking about, and nobody really has, I think, found a solution yet, at least the heavy-duty truck OEMs, on how to challenge the challenges we have with infrastructure, the challenges we have with cost, weight, etc., for a battery electric vehicle, for hydrogen vehicles, etc. So I'm very excited about that, Ian, to hear your perspective and why and how you guys are deploying your technology and how that goes. But to start out with, introduce yourself, Ian, a little bit of your background, share a little bit what Revoy is doing, because I'm sure not everybody knows about it. And then you and I will dive together into Reimagined Mobility, at least in your section for sure, that the industry you guys are working on. And then we go from there.
Absolutely. And yeah, great to meet you, Stefan. So yeah, in terms of myself, I'm an engineer. I'm an MIT educated roboticist. I'm a PhD dropout. And what we do at Revoy is we make an electric vehicle that is able to instantly integrate with any of the 3 million semi-trucks on the road today. And what it does is it brings in renewable electric power, which reduces the power demand on the diesel engine, which reduces fuel use dramatically, as well as emissions by over 70%.
Interesting. Yeah. You mentioned your background in robotics, right? Did I hear you right? Yeah,
that's right.
When I look at your website, it looks like this vehicle, which is like, it's a vehicle, it's a robot, it's an electric battery. I don't know exactly what it is. Maybe you guys have a special name. Does it drive autonomously as well then?
So in the yard, it has the ability to drive autonomously and reposition trailers. Right now, we just remote pilot those because that's the nice and easy thing and practical thing to do. Our take on autonomy in general, and this is really driven by my experience in autonomy. So I was the first engineer at Cruise Automation, ultimately acquired by GM. We made robotaxis. And I think one of the things I've really learned, especially getting into trucking, is drivers are doing a whole heck of a lot. And they are very, very important. You know, the myth of it being unskilled labor is a total myth, right? They are very skilled. They're very experienced. And I think what in general the industry is discovering is it's pretty hard to pull them out of the vehicle and truly replace them with a software system. And so my overall approach to robotics is let's not use it to replace humans. Let's use it to help humans. And so we view our vehicle as a robot of sorts that is a collaborative robot. It's meant to help the driver do their job easier, better, safer, all of the above. And what we're starting with is the displacement of diesel, the reduction of diesel use, but already drivers just love using it. It's a lot of fun to drive. You get that extra torque from the electric powertrain, but also it's a lot safer to drive. Not only do you get that extra torque, for example, a lot of highway on-ramps are not long enough for tractor trailers to get up to full speed, and that's just something that's inherently dangerous when you have different speeds of traffic merging into each other. So our technology can get truckers up to full speed by the end of the on-ramp and onto the highway. But along with that, you can also have additional braking power. So not just traction power, but braking power. So we have regenerative braking on board that follows along with what the driver does. When they hit the brakes, it helps them brake. And we can actually stop the tractor trailer 30% sooner, which is guaranteed to prevent crashes and save some lives. And then when you're at speed on the highway, that's really where the vast majority of the fuel use reduction happens. It essentially acts as a cruise control. And in that scenario, you're actually 100% electric. And the drivers love it.
Yeah, interesting. So then I guess let's stay for a moment. We don't usually necessarily like to dive too much into the technology, but I'm very interested here, so let's do it. You just mentioned when you brake, the trailer or your vehicle brakes or uses regenerative braking. What is the communication link? I mean, for the gas to accelerate, to brake, all this stuff. Is this CAN communication? Is it a wireless communication? How do you do this?
Yeah, great question. So what's really important, just generally speaking, is you don't want to distract drivers. They need to be using just the exact same controls that they're already doing: steering, throttle, brake. Anything on top of that, you introduce an opportunity for distraction. And that's just really important to keep the vehicle safe. So yeah, you're absolutely right. We do integrate with the tractor, but where the robotics magic comes in is that we do this with zero data bus integration. So there is no CAN bus link between the two vehicles. The way it happens is we have sensors and instrumentation in the upper fifth wheel hitch, the kingpin connection to the vehicle. And what that allows us to do is infer what the driver is doing and always follow along with what they're doing. So when they hit the accelerator pedal, we can detect it in those sensors. We assist with acceleration. When they hit the brake pedal or the Jake brake for that matter, we detect that and we assist with that. So it's always meant to just follow their lead. And that gets into our overall robotics strategy, right? Of they know what they're doing. Let's trust drivers. Drivers are very, very good at their jobs. I mean, I've learned that. We have a staff test pilot. Her name's Beverly. She used to haul tankers, which are, one of the most dangerous cargoes to pull. She really appreciates, and she definitely lets us know, how important it is to keep these vehicles safe. And so, what Beverly says goes, both on the vehicle and in our engineering development.
Interesting. So tell me a little bit then, where does this idea come from to essentially almost have two cabs, right? I mean, if you're looking on pictures, it looks like it's a trailer with two cabs, right?
Mm-hmm.
Where did this idea come from? Clearly, you mentioned before it's about safety. It was about emissions reduction, obviously cost reduction in the long run, right? We'll get to that maybe next. But where did this idea come from? And was it for a current need? Was it for kind of what the show is about, reimagining mobility? Was it about in the future we need this, and we don't think in the next 10 years we truly have Class 8 trucks that are either fuel cell or pure EVs for a number of different reasons? Share a little bit about that, Ian.
Yeah, absolutely. So just as a top of the line thing, the main use case here is cost reduction. Electric power is significantly cheaper than diesel power. On a per mile basis, you're paying maybe 60 or 70 cents per mile to get the energy you need to move that cargo. When you source that from renewable sources, that can be less than 10 cents. That is a huge, huge opportunity for cost savings. So forget that it's renewable, forget that it's green. This is going to be a moneymaker for fleets. So now where it came from the technical approach is it's all about how do we deliver that power effectively to the fleet. And so, yeah, we have a lot of big plans in terms of how we're going to reimagine, mobility specifically in the trucking sector. But what really matters right now is we got to meet fleets where they're at. What they're being asked to do right now is throw out their entire fleet of fully depreciated assets that are working and earning money for them and replace them with something that's more expensive and is oftentimes hard to source that cheap electricity. So it's a really hard thing. Typically, it ends up being 30-40% more expensive, and that's where basically every electric trucking project goes to die. It's got to be cost competitive. So with this thesis of how do we deliver this electric power effectively, there was one option, and now there have become two outside of us. So the first option that people were presented with was the electric semi, and by and large, we're not seeing any adoption of that, and it's for both the cost reason as well as a lot of the reasons that I can get into around the operational constraints, specifically around charging, but also around weight. It's really the problem is that the heritage of electric vehicles has been luxury sedans. And when you copy paste that tech stack into what is a commercial asset, you can't expect it to work. You really just cannot expect that to work. And we're seeing that play out right now. So that's the problem with that. Now, there's also been some innovation on the trailer standpoint, adding batteries and an electric powertrain to the trailer. The problem with that is on a fundamental level, it's really, really hard to get a reasonable payback period on this. It all comes a ton to economics. The utilization of trailers is extremely low. There's a trailer ratio in the industry of approximately 4-to-1. So for every one trailer you see on the road, there's 3 sitting in a yard. And so if you're putting all that extra cost, all that extra CapEx onto something that's just going to sit in a yard and not earn you any money, I mean, you're looking at about 10 years before you break even, which is really just a non-starter. And so funnily enough, that's actually how the Revoy product started, is it started out as an electric trailer. And what we found out is exactly this, is it doesn't work for the industry. And there's also, a little bit of problems on the vehicle dynamic standpoint. Generally speaking, you don't want to be pushing from the back of a trailer. The analogy I like to make is it's like pushing rope, right? When you push rope, it folds. And that's something you really want to avoid. And so if you put the drive axles where they're meant to be, right behind the cab, that's what drivers expect. That's what you should be doing. And so what's really cool about semi-trailer or semi-trucks, just from a technical standpoint, is they are already modular vehicles. It's actually really cool when you get down and really think about it. We have a cargo module and we have a power unit module, and they link up and you get all this awesome stuff. Power only is really cool. And so when we think about delivering electric power, we already have a modular vehicle. Why are we so laser focused on replacing one of them? We should just add another module. And that's what the Revoy EV is it's a electric delivery module for an existing modular vehicle. And so, what you get with it is super high utilization. It can be passed between both drivers after they end their 11 hours of service, across fleets, right? It can just be either charging or discharging 24 hours a day. And that's how we make it work. And that's what we've seen play out in our commercial deployments, is it actually works for fleets. Yes.
A hybrid semi, so to speak. So then,
Yes.
what are ultimately, again, maybe not necessarily today, but ultimately, do you see your target customers to be for this technology? Is it all the fleet owners? Is it ultimately also you're looking at maybe I'm actually selling some of these things directly to the OEMs who then provide a complete solution to the fleet owners or the buyers? Is it more used sort of on demand that, hey, I need one of these things today because I'm going from LA, I'm going to Houston, and I need it for that drive. So I'm just going to go kind of sort of a hybrid on demand because I don't want to own it. Share a little bit about that. Again, not necessarily what's today, but as you reimagine the usage of this technology, where you can see it going.
Yeah. So certainly in the long view, we want this to be very much on demand. It's a new energy source, and we already have a great model for sourcing energy, which is you pull over, you go to a truck stop, you fill it up with diesel. And that's what we're really reimagining for how people go electric is you show up with your truck. It takes 2 minutes to hook up. You could have heard about it 5 minutes ago from a billboard on the highway, and you can go over 90% electric. That's how simple it can be. And that's what we've managed to build. Now, in terms of go-to-market and what we're doing initially, we are really focusing on two things. The first is line haul, so dedicated logistics, sometimes it's called that. And the reason for that is basically it's really nice to have regular loads going through an area, and it allows you to book high volumes at a very initial state. When you're doing, on-demand, self-serve, you can call it, it basically makes that a little bit more difficult. And so we really do focus on B2B line haul. The other reason, though, or the other thing we focus on is long haul. And that is something that we almost are the only electric mobility company in trucking that are focusing on that. The whole industry is really laser focused on short and regional haul. There's a lot of stuff happening in drayage, specifically down in LA, Port of Long Beach, Port of LA. The trouble with that is basically cost of energy. In LA, the demand is super high for energy, for electricity. You have a whole mega city there that is all consuming electricity. And so the rates you get, especially when you mix in demand charges, are really prohibitive to adoption. It's hard to actually make it less expensive, especially when you're also incurring a higher cost for the tractor itself, right? That's 3 or 4 times more expensive. The other reason is one, just emissions impact and also market sizing. So one of the biggest misconceptions in the industry that I love being able to talk about this because it is a misconception is, and you may have heard this before, 84% of freight is below 250 miles, specifically Class 8 freight. It's actually not true. It's true in a very narrow sense, and what it is that 84% is by trip count. So a trip that is 10 miles counts the same as a trip that is 1,000 miles. And when we talk about an energy transition, it's trips are almost a nonsense metric, right? It's miles. Miles are how you occur energy. Every time you go a mile, it takes a certain amount of energy. And so when you look at a per mile basis, it's the opposite, long haul. And you ask anyone in the trucking industry, what is the biggest part of your business? Long haul, always long haul. And so our take on long haul is that right now it's a technology constraint. Battery energy density is nowhere near where it needs to be for a long haul truck to operate on a full day without having to stop multiple hours, multiple times per day for a charge. And so that's a non-starter for fleets. I mean, the biggest cost besides fuel is driver wages. And so if you're paying a driver to sit there and wait for a charge, more on the order of half their day, you just can't justify that. You cannot justify that. And so our take is it's not so much the range that's the problem. It's what does the stop at the end of that range look like? And so this is where the aspect of the swap, the Revoy swapping station comes in, which is, okay, you go for 200 miles. That's a pretty standard electric semi range. Instead of stopping and holding that unit down and that driver down, waiting for a charge, why not just swap out the batteries and hit the road again? 4 minutes, that's what we can do. And so what's really cool about our technology and this ability to really quickly and easily integrate with the truck, all it uses is the existing tractor-trailer modular interface. So you can do it in 2 minutes. What's really cool about that is, battery swapping has been talked about for a while, and the challenge with that is it requires really heavy infrastructure, literally lifting batteries out of trucks. But also it's a standards problem. It's an interface problem. You have to have the whole trucking industry decide this is our battery swapping interface. That the ship has sailed on that. Yeah, exactly. But what's really cool is if you're using the trailer hitch interface, well, every single semi truck on the road today is already a battery swapping hybrid today. It's just missing its battery pack. And that's what we're offering is that. So the other aspect of long haul too is you can get out into lower electricity demand areas, also do on-site generation if you need to, and you can get that really large difference in energy pricing that the industry has been promising for a long time. So, as a whole, what we're able to do with this long haul battery swapping model, full vehicle swap, really, it's not actually the battery being swapped, is really deliver on the promise of electrification. And that's what we've been able to do.
Interesting. So would you then fundamentally say that, again, you're a battery swapping company or whatever, but those trucks, those trailers will be then rehooked up to at a Lowe's gas station or at a Buc-ee's, I don't know.
Yeah.
And then
not Buc-ee's, but
again, yeah, I love Buc-ee's too. That's why I have to bring it up.
Yeah, I love Buc-ee's too, but they don't allow trucks, unfortunately. Yeah. But I love Buc-ee's. But absolutely, yeah, it's a refueling process. Rather than the fuel coming in through the tank, it's coming in through a pre-charged battery into the hitch. So, but in terms of how our customers buy it, it's by the mile. It's a pure OpEx model. Our customers do not pay for the chargers. They don't pay for the vehicles. What we commit to them is when you show up, we have a pre-charged Revoy EV ready to go, ready to fuel your fleet, just like any other fuel stop.
Right.
And so absolutely, yeah, it's a truck stop model.
It's genius, I would say. It's a brilliant idea. So then, going back a little bit into the technology, because now I'm very interested in it. So what is the range then? Let's say a fully loaded trailer, whatever the top weight is, I have no idea there, but fully loaded, heavyweight, how long can I go purely EV with one of your battery modules, let's call them?
Yeah, so right now on our current vehicle in market, it's 170 miles of all electric range. Okay. Our next generation vehicle coming out later this year is 240 miles of all electric range at a lower weight point, which is pretty cool. What's really interesting though is one of the challenges with the short range of vehicles, along with the downtime that a charge cycle presents, is range anxiety. That's a problem. That's why Tesla had to build the supercharger network. No one was going to buy a Model S if they couldn't actually drive it anywhere. I mean, obviously, right? And so they had to go out and build at cost a whole bunch of charging infrastructure. And we just have that same problem, not us personally, but us as the industry. Yep. And as a country have that same problem, 10 to 100x fold in terms of the power requirements for heavy trucks. And so it presents a chicken egg problem, and I would love to talk about the chicken egg problem a lot. So let's put a pin in that. But when it comes down to range anxiety, the nice thing about being a hybrid is, let's say you run out of mileage 5 miles before the next Revoy swapping station. It's no big deal. It's, now you revert back to diesel. It's very natural. It just happens in the background. And you make the delivery. It doesn't jeopardize mission success, mission being deliver the goods, right? Yep. Whereas, you look at taking an electric semi to somewhere where the battery capacity fluctuates, for example, at temperature, the north, right? There's a reason why the Tesla semi is only being operated in California. It's because if you go up north, well, a route that you expected to be able to make with that truck one day, it goes to below zero. Now you can't make that delivery. Now you have to send a different truck. Now the Tesla semi is in the yard, just sitting around. Yeah. With us, sure, you don't get as much of an MPG improvement. It's a little, marginal 10, 20%. But it doesn't jeopardize mission success. You could still run your exact same route the exact same way. And that's really important. That's part of just making it work for fleets, right? They need to make their deliveries. It's as simple as that.
Yeah. When you talk about weight for a moment, we as a company do quite a bit in the heavy duty truck space on not only on diesel engines, but obviously on transmissions. We do a lot in batteries. And a lot of the discussions that we have, specifically with batteries, is like, we're concerned with the load that we want to put on, and now with a heavier vehicle, because the batteries are so much heavier, now I need to reduce my load, so now my total cost of ownership changes because I can't haul as much, because, with bridges and with weight restrictions and different regulations in different countries, how do you guys look at this? Is it, well, certain routes I don't have a problem because there's no bridges, so mine, are perfect for this, or yes, there is a problem, but it's offset by the reduction of fuel costs. Share a little bit about that.
Yeah, no, I'd love to. This is something that we've thought a lot about, and is one of the main reasons why customers buy us, is because we have zero impact on payload capacity. Now, that may sound like a bold claim, and I'll tell you why that is. Our vehicle weighs 22,000 pounds, and we're probably one of the only electric vehicle companies out there or trucking companies will actually tell you straight up, we weigh this much. It's because it's such a hot button issue. You have to reload those trailers when you have that extra battery weight. Totally understood. The key comes down to modularity. So the ability to take it on and off is always true, and that helps with the swapping methodology, but it also helps with weight. And the reason is this. What we do is we weigh every trailer we encounter. We actually can do that with the vehicle. We just go up and shimmy it and figure out how much it weighs. We also have scales on site for double checking. And when a trailer is loaded to the gills and you're going to be at 80,000 pounds, even with that diesel semi, we say, okay, go ahead. We'll skip this one, right? It's not the only power unit on board. You can just go back to diesel. If there is battery weight budget that we identify, we hop on, we provide fuel savings, we provide emission savings, we provide cost savings, safety improvements, and we hit the road and do all of that. And so in both of those situations, it's the exact same payload, the exact same trailer, the exact same truck. So there's no payload impact. And when you look at the national average data, what's really exciting about this is we don't need to be perfect, right? 64% of tractor trailers on the road today can handle that extra 22,000 pounds. Yeah. We just need the ability to individually address those vehicles. Yep. But the thing is, you don't know what that vehicle is until it gets loaded, right? And so if you can do it at point of use, well, now you've solved the problem. And so the ability to be a trip-by-trip, trailer-by-trailer decision is everything for weight. And so, yeah, we've solved the weight problem. And obviously, we're going to be lightweighting the vehicle. Our frame rails are double thickness for extra safety right now. The weight's going to come down. We'll go from 64 to 70 to 80 to 90 and ultimately 100. But we can start with the vast majority of the market today. And that's what we should be doing.
Interesting.
Yeah.
So then maybe two more questions.
Please.
As it relates to reimagining mobility, again, in your sector, what do you see next? Is it, I see solid-state batteries coming to give me better power density for the same weight that I have. I can, instead of 240 miles, I can go 500 miles. I can charge them even faster. Is it new materials? Is it new applications? Maybe you go from Class 8, you go to 7 and 6, maybe even medium duty trucks where you see an opportunity. Share a little bit about that as more a final question related to what you guys are doing at Revo.
Yeah, absolutely. So Class 7 and below, I think the current battery stack works really well. Those are typically short haul. The range works for it. We're seeing great successes there. So I think that works great. And the issue just with Class 8 is just how long haul prevalent it is. Now, what do I see in terms of the tech stack, when it comes to batteries or solid state or hydrogen? Basically, I'm not holding my breath. We need multiple breakthroughs specifically on energy density when it comes to batteries. And we need huge breakthroughs in terms of per kilogram cost of hydrogen to make hydrogen economical. And the way I see it is, shippers are asking for this every single time they negotiate a contract. They want it renewable. And it's because they have public ESG commitments. They have their shareholders asking for Scope 3 emissions reduction along with all the other things. And they need it. They want it. And so what I predict in terms of, where mobility is going to go is that the trucking fleets that are able to actually deliver sustainable options to their customers at either a same price point or below, they're going to be earning way more contracts than everybody else. And they're going to have a huge head start in terms of that transition. Basically I see it as, I think a lot of people see it as a far off vision. But I think actually it's going to happen a lot quicker than people expect, at least if we have anything to do with it.
Okay. I think, Ian, I could go on. I have another 10 questions in my head lined up, but we need to wrap it up here. So that maybe final question, and again, totally off heavy-duty trucks or anything we've talked today, but what's the next vehicle you're going to buy and why?
So my plan is I'm actually going to be retrofitting a 70s, 80s era two-tone pickup truck with LFP battery packs for my own personal use because I've been wanting a pickup truck for years.
So you make your own.
I'm going to make my own for fun. Yeah.
Very good. Perfect.
And I just love the styling of those classic ones. You know what I'm talking about? The two-tone. Oh,
yeah. No,
beautiful.
I get it. Well, you're not the only one. We as a company quite often get some inquiries about that. The problem is for us to do you're looking at somebody that has to spend millions in order to get this and get the truck safe. If you can do it safely by yourself with components you buy, it's a whole lot easier, right?
Yep.
And it's a great project for sure, and a product at the end, I'm sure. Yeah.
Absolutely. Yeah.
Thank you so much, Ian. This has been super interesting for me. And like I said, we could keep on going, but this is definitely the type of stuff we want to talk about in this Reimagining Mobility podcast series here. And exciting what you guys are doing. Thank you so much.